All right, let's see. Yeah, so let's talk real quick about the final project. All right, so these are very, very generic requirements, right? It's a minimum requirement set. So you're welcome to go beyond. There's no reason for you to, you don't need to ask me permission on whether I could work on this, that, or the other. As long as you're within these requirements or you exceed the requirements, then you're good to go. You know, try to keep it clean. You know, PG-13. You know, and then you're good to go. Okay. So yeah, there are few requirements that everybody has to meet. If you're undergraduate, the requirements are just a little bit less stringent. You know, if you're a graduate, you know, you'll have just more work to do. But let's see. So a couple things. You need to come up with a user data model, and so there's going to be three project related assignments that are going to be spaced about 2 weeks apart. And the first one will ask you, come up with a design. You need to come up with a UML diagram with the following things that you'll need to have on that diagram. The next one, you'll have like a working prototype of at least doing the queries and mostly focused on the database and implementing that database. And once you have those queries, you'll need to be able to interact with it somehow with some user interface. You need to be able to send queries to the server. The server has to be able to respond, and you have to display it in some form. Okay. We don't have any requirements on the front end. If you want to do it, if you want to do just a console application where you can you actually type the commands, that's fine. I know some of you are just on like mobile applications, and if you've done that before, then sure, you can play with that somehow. If you've done some front end in .NET or Java, you're welcome to do that as well. Desktop application. I'm going to give you a starting template for a web application. If you're interested in that, okay. But the data model has to have the following minimal requirements, right? You have to have at least 2 user data models, right? So that represents 2 folks, right? So maybe somebody represents a faculty and somebody represents a student, right? They might share a hierarchy where you might have an abstract or from where, like a person, from where everybody then inherits common traits, right? Everybody has a first name, everybody has a last name, everybody pays taxes, so we need a social security number, right? So all those are common to everybody. And then a faculty might have an office, or they might have whether they're tenured or not, right? So they might have fields that are not, that a student might not have, right? So you'll have 2 data models for 2 distinct types of users, okay? And by distinct means that they'll have some data that the other one does not have. They might share certain things, attributes, but there might be things that are very specific to each individual or type of user. Make sense? So then you'll need to come up with domain objects, right? So a domain object is that so as I mentioned earlier, you're free to choose any topic you want. Yes. And when I say domain, I mean like a topic or subject, right? So if you choose food or sports or entertainment or movies or music or whatever topic you choose to build an application around, there will be certain classes or types of objects that you will find in that subject. Yes. If it's music, you might find songs or playlists, right? Or favorites. If it's movies, you'll find actors and movies and theaters, right? And you'll have they all could have they'll have reviews. If it's food, you might have recipes or ingredients, right? So those classes or those types of objects is what I refer to domain objects, right? Objects that you find only in that topic, only in that subject. Make sense, right? That you would not find in any other topic. Okay, so if the topic is movie, well, you will not find movies in it in the topic of sports, right? And if you're into sports, you might have a coach, and you might have players, and right, and meets, which you would not have in the domain of movies, right? So you need to have at least, wait, 3 domain objects. Yes, at least 3 domain objects, right, that are specific to the topic that you choose. Okay, well, you have to have at least 3. Then you have to have relationships between the different objects and classes and whatnot. Okay, you have to have you have to have at least 2 user to domain object relationship. So a user might be related to a domain object. So users are human things, right? Human that represent human beings, and domain objects are non-human things, right? Like movies, playlists, songs, ingredients. Those are non-human class diagrams. Yes. So the requirement is that you have to have at least 2 relationships between a user class, right, and a domain object. Okay, so somehow they have to be related to one another, right? A user might have a playlist. Okay, a user might have a favorite song. Right? So that favorite is the relationship between a user, a human, and a non-human. Make sense? So you need to have at least 2 of those relationships between human and non-humans. You have to have relationships, at least a relationship between, at least 2 relationships between 2 domain objects. So between 2 non-human classes. Right? So a playlist has many songs. Okay, a movie can have many awards. Okay, so those are relationships between non-human things. Right? So you have to have at least how many? At least 2. Then you have to have also relationships between users, between one user and another user. Right? A user might follow another user, right? Or a user might send a message to another user. Right? So that's data that you need to keep track of. Some user is somehow related to another user. A user might be somebody else's manager, right? I might be your manager. Yes, you work for me. So that's a relationship between a user, a human being, and another human being, right? So you have to have I don't know how many, maybe just 1. Oh, okay, yeah, so this is only for graduate students. And then you have to have at least 1 inheritance relationship, right? So where you have a base class, right, and you have couple of inheriting classes that are inherited. You have to have at least 1 portable enumerated data type, at least 1 portable enumerated data type where you have maybe a roles table with faculty, students, staff, or maybe the quarters, or maybe the movie genre with like horror, comedy, drama, sci-fi. Yes. All right, so that's the minimum for the data model, right? So a UML class diagram needs to have all these things. You can have more. This is the minimum. So for user interfaces, there's only a few types of operations that you can do with any data type, right? With any table, right? You can do an insert, an update, a delete, right? You can do a select. Okay, those are the only operations really, right? You can either retrieve data or you can update data, and the update can be either deleting, inserting, right, or updating a data that's already there. Okay. Now in the read and the retrieval, there's only a few types of retrieval that are very common. One of them is I want all the data, select star, right, from a table, and you don't have no criteria, right? So presumably you want to consume the entire content of the table. That's one of them, a very common. Find all whatever, find all courses, find all users, find me all the movies, find me all the reviews, find me all everything. Yes, right. And then the other one is find a particular record, give them a primary key. Yes, that's also a very common query that you'll find implementing quite a bit, right? And then there's the generic, find by some criteria, right? Find me a user by their username and password because I want to log in, right? Find me folks that like a particular movie, right? So you have a generic criteria. Yes. Okay. So there's only a set of types of queries, and so for user interface, you have to, for every table, for every table and for every relationship, right? And well, it depends how you want to implement it. You need to be able to retrieve a set of records, okay, where you can display some form of list or table or some tabular format, yes, where you can see either the entire content of the table. You can go just, I think that's the easiest thing you could do. Just display the entire content of the table. I mean, if you want to get fancy, you can do some pagination, right, and just go 10 records at a time, but no need to get fancy, right? Usually, you would not just display the entire content of the table because you have thousands and thousands of records, right? So if you want to get fancy, usually you would have some kind of cache mechanism, but that's not the point of the project. But you have to have at least one user interface that allows you to display the content of the table. Now, if you don't want to get fancy, it could just be some table or some list, right? If you want to start looking at something a little more prettier, you might want to display them in a grid, right? Or only just a few relevant fields as opposed to all the fields. Yes, right? Or maybe that you can format it. One field is a title, some other field is the how many stars or hearts, right? The other one might be the actual content of a tweet, right? And then the other ones might be some references to other tweets or something, whatever, right? So again, you can get as fancy as you want, but you don't have to. It could just very well be just a table, and that's it. Okay. So anyway, so that you need a user interface at least that allows you to look at the content. Yes. Then you need another screen that allows you to interact with an individual record. Yes. Right. So you need a way to select which record you want to interact with. Right. Maybe you could just click on a particular row, right? Or maybe there's a button that allows you to select that record, and then it brings you to a screen that allows you to interact with that one record, right? And what can you do with that record? Well, you can delete it, right? There might be a delete button, right? Or there might be an update where you can type in new values for the record and click save, right? And then it updates and saves the record. Yes, right? The other thing that you could do is that you want to create a brand new record, right? So that that brings you to the same screen, but it's empty. There's no data because you're not looking at any particular record, but it allows you to enter the data for a brand new record. Yes, and then you click save, and it inserts the database. Yes, so those are just the types of screens that you'll need. Right, one that allows you to display the content of all the records, and another one for interacting with an individual record. Again, you can get as fancy or as as simple as you want. Okay, but most applications that are out there are just fancy skins over those two templates, right? Dealing with a list of things and dealing with an individual record. Okay, and then you can paint it and make it pretty, and and just sell it as something more than just that, right? Okay, yeah. So right, so you need to. Oh yes, if there is a relationship between two records, say you have a course and you have and one course might be related to many sections, right? Where whenever there's a relationship, somehow you need to be able to display that somehow, right? That if I'm looking at this course, oh, there's a whole bunch of sections related to that course, right? So you need some mechanism that allows you to manage that relationship. Okay, so for instance, if you're listing all the courses, and that there's a relationship between courses and sections, one thing you might want to do is that if you have if it's a table, one of the fields could be sections. That if you click on that sections, it takes you to all the sections for that course, and then you're back to the list of sections, but not all of them, only the sections for that course, right? So you're looking at the sections for that course, and then you can say, well, I want to go back. You go back to the list of courses, right? Another way that you might want to do it, which is maybe might be a little simpler, is that you first navigate to the course, and then in the individual screen of the course, you might have a link for all the sections, right? Or maybe you could decide that you want to display the sections right there and there, right? You have the course at the top, and then all the sections related to that course. That could be, right? But somehow there has to be a way, right, for the user to establish the relationship or even know that there's a relationship, right, between the parent and the child. Make sense? Right. So a list of records, be able to edit an individual record, and then somehow navigate between the parent and child of records, right? It might start getting a little weird if you start doing many to many, right? If you have actors, right, you might want to see all the movies that actor has been in. Yes. So maybe you have a field that says movies. If you're giving an actor, so you click on the movies, and then you're looking at the movies of that actor. Yes. But then in the movies, you might have a link to all the actors, right? So if you click on the actors, then you see all the actors in that movie. Well, so now I don't know, does it become like a circular, loop where you can, go back to the original actor and then go back to the original movie? Maybe, right? I'll leave that up to you. How is that you might want to somehow display or create those relationships or navigate between that? That's totally up to you. Yeah, so there you have it. There'll be a couple presentations. First, you'll present a prototype where you'll discuss where you are in the queries that you've come up with, the UML diagram, and it'll be a quick presentation just to give you just to let the TAs know where everybody is, right, in the project, and make sure that everybody's on the same page. The second presentation will be a prototype of this actually working, and the last one will be the final presentation at the end of the semester. I believe it's right after the final exam. This all online, Zoom, whatnot, right? And as long as you have the requirements here that you have so many user models and domain objects, and you can interact with them with a user interface, right? The TAs will just check off. It says, okay, well, you have that, or and you demonstrate this to the TA, right? It doesn't have to be, they don't have to like reinstall and they don't have to install it themselves or host it in some server or whatever, right? You can demonstrate this actually working for the TAs. Yes, that makes sense. Are we good? Okay. All right.
Just a quick question. Where can we find that file?
Can you repeat that?
Yeah, where can we find that file about the final project?
Is it not in there?
It's not on Canvas.
No. Okay, let me just post it on Piazza. I'll add it to Canvas, but let me post it on Piazza for everybody. All right. Okay. Yeah. So let's talk about SQL injection. So last week we had started to discuss interacting with a database, right, from applications. Yes. And typically these applications are interacting with humans, right? And humans usually will have some keyboard, some mouse, right, and start typing into input fields. And depending on how we handle that text that the users introduce into those fields, we have to make sure, right, that they're not introducing any malicious set of strings, right, that would thwart our application, right? So here's a XKCD with a a joke, right, on what could go wrong. And it's mostly the reason that things could go wrong is that if you remember when we were playing around with JDBC, right, we were concatenating the string. We were creating the string, SQL string that we were sending over to the server. right? If we wanted to send a select star from courses, right? We were it was a full string, and if we wanted to make that string parameterized, we would concatenate it with other strings, right? For instance, you might pass the ID, you might pass the username, or you might pass some piece of information that we would concatenate in our strings, and so that opens up it opens us up for for security problems that we might have, depending on what that string might be, right? So here's an example of what the joke says, that the school dean calls a student's mom saying, this is your son's school. We're having some computer troubles, and the mother says, oh dear, did he break something? And the dean says, well, in a way. So she says, did you really name your son Robert, quote, close parentheses, semicolon, drop table students, semicolon? Did you really call them like that, right? Says, oh yeah, little Bobby tables, we call him. So presumably the person who was reading this person's name, they literally copied the text, which was concatenated into a query, which caused the drop of a table, right? And then well, we've just lost this year's students records. I hope you're happy. And the mother answers, well, and I hope you've learned to sanitize your database inputs, right? That people can and folks do maliciously send text to enterprises, to companies, trying to identify any vulnerabilities, right? And there's there's packages that you can purchase. A lot of them are open source, that can automatically just go through tons of very well known failures, and that they know how to get in, right? So yeah, so we have to make sure that whenever the text comes in, we make sure it's sanitized. So yeah, something like this might happen, right, where you are reading data from an incoming string that folks have typed, right? And we just concatenate, right? We say select star from users where user ID equal, and then plus user ID. And so the problem is that concatenation at the end, right? So that concatenation opens up us for vulnerability. Now, most of the time, there's no problems, right? We're assuming that this is an integer, right? We concatenate it, and nothing wrong happens, right? And so, the query might look something like this, right? We read the username from some string that is being passed to us as a request parameter, right, in the URL, and we concatenate the username, we iterate over it, retrieve the data, created objects off of it, and nothing happens. But what happens if instead of a username, they type something else, right? Something that they know we might be vulnerable for, right? So for instance, here's a very common one, right? Sending the one equal one string as part of the query, right? So this might work something like this, right? We'll have the link posted seems to be the dog for homeworks. I think I sent the wrong query. I'll send it a little later at the end. Yeah, so for instance, we in our query would have expected just a username Alice, right? But they might send something else, right? They might send maybe a close quote, because open close quote, because they don't even know nobody's username, right? But if you concatenate at the end something that is always true, right? The query will instead of filtering by username, will not filter by anything, right? Instead, it'll respond back to the user interface with all the data. That was not our intention, right? Right. So somebody's filling out at a form, and we would expect them to type in Alice. We send the Alice in the username as part of the URL. Here, now this might be the form that they're filling out, right? And we pass it in perhaps as a parameter. Oh man. Okay. And so we send in the username, and it comes back with the appropriate response, right? Which would be that individual unique user with their ID, their username, perhaps not the password. But what if instead of just passing Alice, right, they pass in anything? Doesn't really matter what they pass, right? They might pass username, open quote, blurb, whatever, right? Foo, close quote, or 1 = 1. That gets concatenated in our query on something that is always true, right? It doesn't matter what username I gave you. So the response is as if you would have done a select star from users, right? And you retrieve every single record, right? So now instead of the person just receiving one record, they receive the entire table, right? The entire content of the table. And so they might use it as additional information, right, to try and thwart their way into our data. Another very common one is using the quote, close quote equal close quote. Again, this might be useful when the form is asking for 2 or more pieces of information, and you submit it, right? And then they might be sent over across the wire as parameters, right? And then in our application, we might be reading those parameters from the path, and then using them for concatenating them in something like select star from users, where username equals username and then password, right? Now, again, most of the time this is not an issue. Folks are actually passing in actual username and passwords, and they will be getting one single record back, right? Or somebody who's trying to be attack us somehow, right? They might send a close quotes, username is equal to nothing, empty string, right? Or empty string equals, right? And you can go going. So these empty string is basically saying, I don't really care what the password is. I don't really care what the username is, right? But these ors will cause, close quotes equal to close quotes, empty string is equal to empty string, which is true, right? And then cause the response to come back with all the result sets instead of none. Other statements that what they might do is that they might assume that you have a statement. They might close that statement, make it irrelevant. Make whatever query whatever original query you might have, they might render it irrelevant, so that they tag along an additional piece of query that once that executes successfully, it then executes yours, right? So for instance, and tagging at the end of the query, dropping a whole table, which dropping the debt table might not be as bad. So here's an example where we might be expecting a user ID that's being concatenating at the end, and that if we pass in just an actual user, nothing bad should happen, right? But if we pass an ID that might not be even relevant, right? Or we might have captured this ID in the previous query, right? We might have thrown a query earlier, and we might have discovered several IDs, actual IDs, right? Now that we have the ID, we can come back here, right, and start sending actual IDs that might be successful, right? And then adding some other concatenations such as dropping tables and whatnot. Okay. So how do we solve this? So to solve this, it's actually very easy to solve, right? Already the libraries that you will be using, they most likely will have versions of the API that will allow you to deal with sanitizing these queries, these strings, right? In JDBC, to do that, instead of using the statements that we've been using so far, right, which are relying on the concatenation of strings, instead, a prepared statement is much better, right? Instead of relying on concatenation, they parse the string, they compile a string so that you can then iteratively interact with it and fill in blanks, right? And it'll make sure that those blanks are filled in with the correct data type, right? If it's expecting an integer, right, it will not let you pass in anything other than an integer. Right, if it's expecting a date, right, it'll make sure that the string is parsed as a date. Okay, so instead of using the statements that we were using earlier, now we would use instead the prepared statements. Right, so the prepared statement, the way you use it is that you would use connection.prepared statement. You provide the string, And instead of relying on concatenating additional strings, you declare placeholders, right? Placeholders that will be filled in at a later time when you have actual values for it, right? So for instance, if this were, a select star from users where username equal whatever, right? We have a placeholder. Instead of having to concatenate the username later on, right? You can use the statement to fill in that particular placeholder, right? The first placeholder, right? So placeholder number 1, I'm putting there a username. It's a string, right? And this set string, right? First of all, make sure it's the correct data type, right? It's not an integer, it's not a date, it's not a Boolean, right? And make sure that it's strongly typed, right? And also make sure that that string doesn't have any funny characters, right? It doesn't have any dashes, parentheses, semicolon, quotes, or anything like that might be malicious, right? So make sure that if it sees anything like that, it will throw an exception, right? It won't let the execution of the prepared statement. Once you have that, then you can execute the query and use it as the result set like you would in using the normal statement. Yes. On what? Node.js, like JavaScript? Yeah. Oh yeah, definitely. And even Node, right? You would use not JavaScript, but you would use TypeScript that is also strongly typed. But even JavaScript has just simple numbers, date, strings, and it would have the same type of API that would parse and make sure that you can cast it to the correct data type, or at least sanitize it, right, and make sure that you don't have any weird characters in there. But yeah, that's one of the reasons you definitely want to go with strongly typed languages. Yep. Yep. So this just goes through the same examples as before. That now, if you try attacking it with the same vulnerability as before, right, you get just an empty array, as opposed to all the table content, right? Same thing over here, right, with the equal, quote equal quote, right, where you have you instead prepared the statement. Now in this case, you have 2 placeholders, the first and the second, right? And instead of concatenating the username and password, this gets compiled, right? And then you can then modify the placeholders and putting the values there. Again, you have set string, you have set integer, you have set date, you have set float, set Boolean, set all the data types that you would expect, and it'll make sure that whatever you're passing it is the correct data type, and that it doesn't have any weird text in there. The other benefit that is not relevant to SQL injection is that this executes much faster, right? And especially if this is a query that you're going to use over and over and over, right? That maybe inside of a loop, right? You're looping and you're sending all these select statements and inserts or updates inside of a tight loop, right? You need to do something for 1,000 records. It would be very, very expensive to use just plain old statements, right? Because first is concatenation, string concatenation, which is expensive. Plus, every time you create a statement, that's expensive also, right? From the connection, you have to create a statement. Those are objects that are very expensive to instantiate, as opposed to this gets instantiated only once, right? It gets compiled once, and then you can just reuse it over and over and over just by changing the placeholders, right? It gets compiled on the server. The server already has the statement ready to go, right? It just needs the parameterization to run these. So yeah, so not only does it serve well for protecting us, it also for performance issues, it's also much better. So yeah, so this just goes through several examples on where you use placeholders for prepared statements as opposed to just plain old strings. Okay. All right. Okay. All right, let's talk about ORMs and JDBC. So ORMs, when we mention ORM, we mean that we're looking to create a relationship, right, between the objects. Right? We want to create a mapping between the object world and the relational world. Right? We've been spending most of our semester on the relational world side. Okay, we've been talking about tables and how they relate to one another using primary key and foreign key, right? And joins and whatnot. Yes. Now, that's all and good, but at some point, all that data needs to live. At some point, needs to be mapped into an object world, right? Into an actual application that is running on your PC, right? And interacting either with a user, right? And doing some computation and user interface and whatnot. Okay. So we need to think about all of the challenges that exist of converting this this one world, or on how we are formatting the data in one world and how it's formatted and represented in another world, right? And that there are many things that need to be considered when you're doing that transition between those two different worlds, right? The relational world is it's flat, it's completely flat, right? You just have a whole bunch of tables, and there's no hierarchy. The only way that we can fake hierarchy is that you have these foreign keys, primary keys, right? And that kind of creates a hierarchy of relationships between parents and children. Yes. Whereas in object-oriented programming, we have much richer ways of establishing relationships between objects, right? Usually we can have objects that have arrays or linked lists or collections of other objects, right? And those objects can have collections of other objects, right? So you can establish a very rich semantics on how these objects are related to one another in composition, aggregation of other objects. Yes. You also have obviously inheritance, where you have like a parent-child relationship, that children inherit features of their parents. So none of this exists in the relational world. Yes. So when we want to go and read data from the relational world and bring it into the application, there are some challenges that we need to consider, right? It's not one-to-one. Okay. Yeah, so there are many, as I mentioned earlier. So these differences between these two worlds are often referred to as the impedance problem, right? There's a bridge that you need to cross, right, between these two worlds that are separate. Okay, there's a lot of transformation that needs to happen between these, and oftentimes there's no one-to-one matching on how do I represent this in this world and how do I represent it over here. Okay, we saw a couple examples of inheritance a while back, right? And let's talk about a couple more. So how is that we would do this? So relational world, right? You would usually start off with some class diagram, and where you establish perhaps a one-to-many relationship between perhaps one course has many sections, and and obviously the attributes that they might have. Now, typically if you're implementing this in Java, the way you implement this is that you would have perhaps a course has an array of sections, right? That's how you would implement this in Java, and it would be the course who has references to the children, right? The whole has many parts. Yes, you have the array here that have many instances of sections. That's how you would implement it. Now, when you're implementing in a relational world, it's kind of backwards, right? The way it's implemented in a relational world is that instead it is the sections who have references to the parent, or the sections say, hey, I belong to that course over there. The course has no idea about the sections. They have no references, right? So wait a minute. So it's kind of backwards to the way you think about it in object orientation. Object orientation, you use an array on the parent and the child. Usually the child would have no references back to the parent, right? It is a one-way directional. There's only one direction in the relationship. It is the parent who knows about the children. Usually the children don't have a reference back to the parent, right? Whereas in a relational world, it's two ways. Okay, the way that you can navigate between the section in the table and the parent and the child either way, just by doing a join. And a join allows you to access either the child or the parent. Now, you can say select, fields from the parent and fields from the child. Yes, right, where the foreign key of the child is equal to the primary key of the parent, right? And you can navigate between you can grab data from either one. which you could not usually in Java, you would not implement it that way, although you could, but normally you wouldn't. Right? It is only the parent who has references to the children. So already, creating relationships is not the same, right? Here in the object world, right? We need to know about these differences. But in general, we can make certain assumptions, right? That for every table there will be a class, right? That for every column there will be a field, even fields that we would not normally have, right? So, for instance, in a class diagram, in the class diagram typically we don't have primary keys. Yes, the same thing if you're doing an object-oriented programming. If you do an object-oriented language, so Java or .NET, usually you would not have a primary key field in your class, right? The objects already are unique. Yes, they already have a reference in memory, or they have a pointer or an address that they belong to in RAM, and that makes them unique enough. There's no need to have a primary key. Also, usually we have some mapping between the data types, right? The dates in Java, usually they map to some kind of date time in SQL, right? We don't have Booleans in SQL. We have maybe tiny ints, right? That might be mapping to Booleans. So we need to, decide, what is that we're going to use on both sides of the data types and what they're going to match to each other, right? Or primary keys and foreign keys on the relational world, right? They will be mapping to either a variable reference, right? Or there might be some collection, maybe an array, a list, or an array list, right? That maintains references to other classes, other objects. Yeah. So in Java, the way you would implement it, we discussed this. I think it was last week, on how is that you would go about implementing that, right? We would create what is called a DAO, right? Data access object, right? That would host all the functions that you would normally need to be able to interact. Yes. So here's just a quick example that I believe we went through the example last week. Did we? I think it was before the exam, or maybe not. We'll go over it today. But let's go over here in the slides. Say you have this. So you have this table of courses, and we insert several courses, and then you insert and create a table that contains sections where the sections have a foreign key to the course, right? So there's a one-to-many between course and section, and you insert a whole bunch of sections that belong to certain courses, right? So notice that we have these two sections belong to course 1, these 3 sections to course 2, and this 1 section to course 3. Yes. And so these are some of the more common queries. You would have select star from courses. You're retrieving all the courses, and then you might be doing a join between the two, courses and sections, where the foreign key of the section, right, is equal to the primary key of the course. Yes. Right. So these are two common queries that you might have, right? So how do these map? How are these implemented in the object world? Yes. So in the object world, you would start with, the assumption that for every table there will be a class. Right. So if there's a section table, then there will be a section class. Yes. And there's a courses table, there will be a course class. Obviously, you would make sure that you follow the naming conventions on either side. In the relational world, they are all lowercase and they are plural nouns, whereas in the object world they are capitalized and they are singular nouns. Yes. Also, same thing for the names of the fields, right? The fields are camel case in Java or in the object world, right? And they're all lowercase and have underscores between words in SQL. So here's some data types. The primary keys here, we're representing it as integers, the title as a string. Notice our foreign key in the relational world, we have substituted with an actual reference to a course. Normally, we would not do this. Okay, if they didn't tell us, if they just gave us this, right? there would be no hint that the section should have a reference to the course. If it is a relational world, then yes, definitely the section will have a foreign key to the course. But if you're implementing in Java, we would never even consider having that the section would have a reference to the course, right? Just like we would not in Java or .NET, we would not have a primary key either. Okay, the only thing we would implement here is that these two strings, yes, and the course would have an array of sections. That's it, and we're done, right, for the object world. But because we know that we're trying to map these two worlds, we're trying to bridge that impedance problem, yes, right, we're going to go a little farther, and we do create a field where we can hold the primary key. We know it's data that is stored in the relational world, right? We need a place to hold it here in RAM, in memory, right? And that course, we know that that's a foreign key. It has an actual numeric value that is equal to the primary key of some other record. Yes, and that would be way too low level, right? The way we would have to implement it here would be an actual integer, yes, that holds the ID of the course. But that's way too low level, right? Instead, we're trying to go a little higher level. Instead of the ID of the course, we would make an effort to actually fetch that course from the database, create an instance of that course, yes, right, and then assign it to this variable. And this variable would point to an object instance that would contain the data of the course in memory. Make sense? Right? And again, those are all architectural decisions, right? When you're starting to build these things, how far do you want to bridge this? How high of an abstraction do you want to create? Are we gonna just stay in the primary key, foreign key world of just numbers, or do you want to add a little more, nuanced here, right? Let's see what else. Then we would have obviously all the setters and getters for each one of these, right? You will have the setter and getter for the ID, for the title, for the course, right? You would have the constructors and whatnot. Yes. Yeah. Here, these are all the setters and getters. Get course, set course. So here's the first question, right? If I have a query in my object-oriented application that says retrieve for me all the sections, I want to list all the sections. Yes. So the question might be, wait a minute. So what is it that you want to display? Usually the first question is, in that user interface, what is it you want to display? You want to display the ID of the section? Maybe not, right? You probably want to display at least the title of the section, right? Maybe how many seats and and how many whatever, right? How many people have registered and who's teaching it, blah blah blah. Yes, but one of the things that you might not want to display is the course, right? The course that it belongs to, perhaps, just a section, right? And so the question might be, well, why did I even bother, retrieving the information of the course? That's an extra query. That's an extra join, to bring in the information for the course, right? To populate this course object. Yes, right. So probably I only want this course information only if you really want to know, right? And on demand. If you do ask me what the course is, yes, I'll go fetch it and I'll populate this object for you, and then I'll display it in the user interface, right? Otherwise, it would be too expensive. Say I want to list all the sections, right? And there's 10 sections. Am I going to do 10 joins to go fetch the course information that probably you're not even going to need? Probably not, right? So these design decisions, right, are what the kind of folks are asking themselves, right, on how to bridge these two worlds, right? If I'm in the database, sure, I'll do the joins, right? And I have a result set that gives me information about the sections, the information about the course. But should I go further and instantiate all these objects in memory? Probably not, right? Probably I just want some of the information just to display the sections, but not necessarily everything on the course. Yes. So this strategy is often referred to as lazy loading, right? You load the information on demand only if you really need it, like a need to know basis, right? And you can typically, this is a usually some of these libraries that we're going to see a little later, right, allow you to establish what kind of policy do you want. Do you want a lazy loading policy? Do you want it to be or eager loading policy? Right, eager meaning if I ask you for the sections, I also want you to load everything that section refers to. Right, load everything, do all those joins, bring all the instances. I want the whole object actually filled in. Okay, and again, it might make sense for certain types of applications. Okay, but yeah, when you're implementing these types of applications, these are things that you might want to consider, right? Lazy loading, eager loading. Okay, so right. So what about from the courses side? So from the courses side, right? Again, we have the integer, which is representing the primary key of the course. We have the title, whatnot, right? And now the sections, right? Remember, from the relational point of view, relational world's point of view, the course has no information about the sections. Right? It is a section that has foreign keys back to the course. The course has no information about the sections. But from the object world's point of view, that makes no sense. Right? The way you would think about it in object orientation is that this is either an array of sections or a list of sections or an array list of sections, some type of collection, right, of sections, or maybe some iterable list of sections. Yes, right. And this is how you would implement it. Again, if this were just Java or object oriented, this is the only thing you would do. You wouldn't bother for sections to have references back to the course, right? So yeah, and this is again the lazy loading or the eager loading. If I want to list a list of courses that I'm teaching today in this section, this semester, would I also load all the sections? Maybe not, right? It says, okay, I'm teaching all these courses and whatnot. I'm responsible for these courses, and I'm listing the 4 courses that I'm teaching this semester. Do I also list the sections? Well, probably if I click on the section and then it navigates to a different screen where I can see the sections, and then is when I would load the actual sections from the database, right? Probably not all of them. I mean, imagine the dean wants to know all the courses that they're being taught in the school, and it might be hundreds of courses that are being taught. Am I going to also join with all the sections, right? Even if I'm not going to need it to display for the dean's screen? Probably not. So again, here's where you would decide that perhaps this is a lazy loading, right? And I would load it only on demand. So yeah, courses, whatnot. All right, so I if I'm using JDBC to load all this data, these are the typical queries that I would have, right? Select star from courses, and then a prepared statement, right, that will allow me to read the sections for a given course. Yes. So our API, where you would have a perhaps in a DAO, a data access object that is dedicated for courses or sections, you would have something like this. You would have a find all courses. These are one of the many finders you would have, right? And you would get a connection, right? You would initialize a courses, right, where to fill in as an array or collection of courses that you would retrieve from the database. You would prepare the statement, and you would use the statement to execute the query, and then you would iterate over the result set that would come from the server, right? Database servers, which looks something like this. As you iterate, right, you retrieve the IDs of the course and the title, perhaps somewhere. Here's the title, okay? And you would because you have the course ID, you could prepare the statement for retrieving the sections for that course, because not only do you need to load the to instantiate the course, not only do you need to load the ID and the string for the title, you also need a collection of sections. So as you are loading the course, this would be an eager loading, right? I'm reading the information for the course. I'm reading the information, the title and the course ID. But now that I have the course ID, I can also run the section, this select star from the sections, right? And do the join, so I can fetch all the section information as well. So as I am iterating over the courses, I can do an inner query that I can retrieve the sections for that course as well, right? So I'm reading all the sections, for that particular course, right? And that gives me a result set for that course, which I can then use to instantiate the course with those sections, right? That is filling in the sections array here that I can then use to instantiate the course. So this would be an implementation of an eager loading, right? I'm loading the course, and for every course, I'm also loading their sections. I put them in a collection of sections, which I then can use to instantiate each one of the courses, right? So this is not lazy. This would be eager, right? If this would be eager, I would not have this inner query, right, to fetch also the sections for the course. I would leave it for later, right, to fetch them a little later. Anyway, let's introduce the assignment, and we'll revisit this code as part of the assignment, and so I can introduce that as well. All right. Let's see, what are we doing with time? All right, let's take a really short short break, and then we'll come back right after these messages. Oh, let me send you the link. I believe I've updated the query, the URL to the project. It used to be the assignment. It should be the correct one. Can someone check? All right. Okay, let's take a look at the assignment for this week. So the assignment asks you to create two types of DAOs, two data access objects. So if you remember, data access objects are design patterns. They're the best practices on how we should write a program to access, to interact with the database, right? And the basic idea is that you should try to centralize access to the database into a single class or a set of very well tight related classes that are responsible for interacting with the database, right? And providing a nice, clean, high-level API to the rest of the application, right? So that the rest of the application is doesn't have to worry or have to know any details or any idiosyncrasies on how is it that you interact with the database, right? Only the data access objects knows that you need to establish a connection, you have to log in, and certain data types, and whether it's lazy loading or eager loading, and all those things should be very well defined by the data access object. Yes, the rest of the application should be shielded from all these idiosyncrasies. Make sense? Okay. So we're asking you to write two data access objects to interact with the same data model, right? And the data model will be just a simple table of users, right? And you're first going to be using just plain old JDBC, right? And you'll create a data access object using JDBC. It'll be very tedious, right? You'll have to create all the finder methods, the create, the update, the delete, establishing a connection with the database, closing the database, logging in, iterating over the result set, right? And now I only ask you to do one of these. Right? Now, if you've been around long enough, right, and you write several of these data access objects, you realize that they're all basically the same, right? They all look very, very similar to one another, right? And so a better solution might be that that you have a generic data access object, right? A mechanism that allows you to, have a data access object which is smart enough to not have to write the same boilerplate again, right? That you could just parameterize it, right? And that's the idea of the object relational mapping libraries, right? There are libraries that will implement for you a data access object, and without you having to write it from scratch. Okay, so actually, before we go into the assignment, let me actually go over that real quick. Okay, so the ORM tries to bridge the gap between the relational world and the object world using these kinds of templates or using these patterns that we've already identified. As good programming software engineers, whenever we start writing the same code over and over, right? We start identifying patterns and say, wait a minute, could I find what's the same across all these DAOs, right? And identify the things that are different. Okay, and so if I extract the things that are the same, could I parameterize it so that I could pass in all the things that are different, right? And then it could behave with for any for any one of the solutions. Yes, so I could have one database access object which could behave like any data access object, right? And that's the idea of the ORM. The ORM bridges this gap by creating these generalizations. Now, there's a whole bunch of ORM frameworks out there, depending on what language of choice, what technology stack you are using, right? There's for .NET, there's for Python, for PHP, for Java, for any possible language that you can think of, there will be some kind of ORM solution, okay? And even within that same technology stack, there will be different vendors that compete in that space, all right? So for instance, in the Java world, I mean, there's Eclipse-Link, there's Kodo, JDO, EJB. EJBs were the original ones, the very, very first ones. Okay, when this first idea first came out, right? And they were horrible. Everybody hated them, right? They were so hard to use. Then Hibernate came along and and really came up with a really, really nice solution, really, really easy to use. And today is kind of like the standard. JPA, which is the Java standard for object relational mapping, is heavily based on Hibernate. Okay, there's still other solutions out there. Again, for every single technology stack, there will be an equivalent ORM solution, right? We're going to be focusing on JPA, which is just one in a sea of object relational libraries out there. It is the standard in Java. So it and basically what it does is that it automates the mechanisms by which we would write a DAO, right? And so instead of having to write it from scratch, right, they give you a parameterizable DAO, right? And the only difference, if you look at an insert statement, right, in a DAO for courses, and then you look at one for sections, and you look at one for users, the only thing that changes between them is that the name of the table, right, the fields, right, and the data types of the fields. That's the only thing that changes between one DAO and the other. But everything else, establishing a connection, right, and executing the query, and then parsing through the URL through the result set, right, and then giving you all the values of the field, and then instantiating each one of those objects and putting them in an array, and then returning that array. That's all the same. The code is all the same, right? You just have to give me what the table is and what the fields are, right? And that's exactly what these ORM mechanisms do. So usually, I am giving you a starting point, a repository that you can use as a starting point for the assignment and also for this presentation, which is here, right? And so you'll need to clone that down for this to work. So another thing that we're going to be doing is that if you look at the code that we've been looking at so far using the JDBC libraries, even though we say it was Java, and Java doesn't, it's written so that it's compile once, run anywhere. We kind of broke that that mantra, right? Because we had in our code, we had the driver, the name of the driver was there, right? So that kind of makes you dependent on the driver, right? So if you don't have that library, that code won't execute. Also in our JDBC code, we did have the URL to connect to a database. Yes, so that kind of also breaks the idea, because that makes you dependent on that particular vendor, on that particular server running at a particular port. Yes, on that particular IP address. So it creates a lot of dependencies between the code and what you're using underneath. So whereas ORMs absolutely don't want to have any of those dependencies in the source code. Okay, so instead, they say, well, you'll need to configure that elsewhere, right? And usually it is through some either an XML file or a properties file that has name value pairs, right? And these name value pairs configure everything. So here's an example of what that might look like, where you have you you establish elsewhere in a configuration file what the URL is, right? That you're going to be using MySQL, and the URL is going to be some host that you're going to realize at runtime, right? That at a particular port number and whatnot, right? And the database schema that you're going to connect to. Also, the username and password is also parameterizable, usually by the environment that you're using, whether it's a development environment, your machine locally when you're developing, or whether there's a production machine, or whether it's a QA machine. And each usually in an enterprise, you just don't just have one database, right? Usually you have many databases. You'll have yours running on your machine. Then there'll be a development environment where the development team uses one database, right? Then there'll be a QA database, right, where the QA engineers test your source, and then there'll be a performance database, right, and UAT database, and blah blah blah, all the way up to production. So in each environment, you'll have a different set of your username and passwords. They'll have different host names, right, different schema names, and these needs to be configurable so that it can work at any. You can work at the same code can be executed and run in all these environments. So you need to be able to manage those dependencies. Oops. Other things in these property files, it will probably have other things such as whether there's some testing or some error handling, or whether your code can either work with a legacy database where the schema is already set and you cannot modify it, or do you want to give your application the capability of modifying the schema? Usually in a development environment, you might want to say yes. As you're starting developing, maybe you want your code to make changes and updates and alters of your local schema. But once this gets up to production, usually you don't have that, right? The schema is set in stone, and you don't have any modifications in production. You're maybe in a development environment, but not in production. Then also, obviously, the POM file in Java. Usually, you have an additional POM file that configures the versions of your JVM, and also the version of the database, particular database, MySQL, that you're using, and whatnot. Yes. Anyway, so going back to the original example that we saw earlier, of courses and sections and whatnot, the same courses table, the same sections table. We're inserting a couple of courses, inserting a couple of sections, right? So our ORM, just like we were, when we're using JDBC, we were aware of the low-level differences, right, between how things were named in relational database and how things were named in Java. Our ORM, since we're going to automate a lot of this, right, should also be aware of these differences, right, between these two different worlds, right? The ORM should be aware that in Java it is case sensitive, whereas in database it's not case sensitive. Where in Java we're going to use camel case, and it should automatically know that the naming convention in the relational world is underscores, right? And that we use plurals or singulars. Okay, so how do we do the mapping? How do we automate this process? So to automate the process is as follows. You first start with a plain Java object, right? As you were implementing just a normal object-oriented program, yes? With a minor understanding that you are going to be mapping this to a database. So for instance, you might add in there things such as primary key, only because right, this is going to be mapped to a table at some point. Yes, so you might write your Java class like that. Right? But other than that, there's nothing peculiar about this class. There's nothing special about it up until you start using the actual ORM. Right? When you start using the ORM, you start, what do we call? We say we start annotating. We start annotating the class with some special magical incantations. So for instance, the first magical incantation here is the @entity annotation, right? @entity is part of the Java ORM library, right? The Java ORM library declares a whole bunch of annotations, all these whatever, yes? Behind the scenes, these are actual classes. Right? These are actual classes that extend your class and take over your class, right? They modify your class, which you are completely unaware of, right? You just do the annotations and follow documentation, right? And all the magic happens behind the scenes, right? So one of the magical things that happens here is that by annotating this class as @entity, you're automatically telling the ORM, hey, there's a table called course in the relational database, okay? And I want you to try map this class to that table. Try look for it, right? Go find it, okay? And the JPA library will start looking for this table, right? It will get very upset if it doesn't find it. It starts putting squiggly red lines everywhere. It says, I can't find the table, right? The other thing that you can do is that if it doesn't find it, because the table is actually called courses, not course, right? You can override the default, right? The default is by just annotating entity, is that it will assume that there's a table called course, all lowercase course, not plural, singular, just like the name of the table, the class, right? And the reason it doesn't go to plural is because, well, pluralization in English is not very easy. It's not always just adding an S at the end. So the JPA team just decided, whatever you call the table, whatever you call the class, we'll go with that, with the name of the table. If you want to override it, you can, like this. You can override it with @table. You can say, well, the table is not actually called course, singular. It's actually called courses. So you can specifically tell me the name of the courses. This is an optional annotation. It's not actually needed, and only if the name of the table and the class don't actually match, right? Now the library is going to start saying, oh, I found the courses table. There it is. I found it, right? The other thing that that you can do is, oh, yes. Yes, plural. Plural, all lowercase. Yep. Nouns. No, like for instance, web services are also plural. Tables are also plural, as in it's a collection of things, of records, as opposed to a class saying that it's a type, of things that, yes, they're gonna be many instances of courses, right? But it's not being contained by the class. It's only like a template for instantiating, but it's not representing the courses. As opposed to a table, it's almost like it's an array or a collection of courses. So yeah, the pluralization stuck. You would have to, yep, exactly. As opposed to when we go to Mongo, Mongo does, no, not Mongo, Mongoose, which is a Mongo library. It will try to pluralize it, right? So by default, if you don't tell it, right, it will try to pluralize it every time. And it sometimes it doesn't get it. Like if you say fish, right, it'll try to pluralize it as fishes. It says, well, no, that's not the plural of fish, right? So some nouns, so it has a library of all the words. So sometimes you don't want it to pluralize it because it's not standard. You want to take control over that. So a couple other things. Just like there's a default naming for the name of the class, for name of tables, and we had to override it because it doesn't match, right? Notice a couple other things. The title, right? The titles field here matches the name of the field here in the table, so that we're good, right? And just by saying at entity, right, it'll start looking for things that match. Right? It says, oh, you have a title here, and well, it must match that title over there, right? They're even the same data type. I'm good, right? But then it finds ID over here. We had no match on this side, right? So it's kind of start complaining. It says, well, you don't have an ID on this side, right? Or vice versa. You have a course ID on this side, which you don't have a course ID on that side. Okay, and so it'll start complaining and saying, well, you know, these classes, this class doesn't really match this table. Okay, but again, we can start overriding a few things. For instance, we might say that the actual name of the column, is the name is ID. So we're saying that this field that I'm calling course ID on the Java side actually maps to a field or column whose name is ID on this side. Okay, and so the JPA library will say, okay, well, okay, good. It'll make sure that the data types match, right? If this says integer, well, this also should be some integer-like data type. Hello? You still hear me? I think so. Okay. So yeah, it's so this course ID now is mapped to this ID over here. Otherwise, it was looking for, if I don't say this, right, it would be looking for a field on this side called course underscore ID, right? Because it's, you know, it's trying to be smart about this, right? And says, okay, well, I know in Java you camel case things, right? And the way you would call it on this side would you be using instead, you would be using underscores, yes, right? So that's what it would be looking for. It's not finding it. It says, okay, well, you must not have that field. But over here, we're overriding and telling you, yes, I do have that field, and it's called ID. Make sense? So I can override that. For the string title, I didn't have to do anything, right? Because the data types match, the names match, we're good. I don't have to do anything. Yes. Yeah.
So for naming the ID column.
Yeah. Yep.
Short and sweet, but is it okay to just be more verbose?
It's always best to be verbose. Yeah. So there's no especially when you're going to have joins and you're going to have multiple tables. You know, it's clear that the fields are different, right? And that they match, especially when you have like foreign keys and primary keys, you know exactly who's referring to. It's always better. Although, you know, sometimes folks are, you know, lazy and will go with just ID.
But I guess you still have to do the mapping.
Correct. Yes. Yeah, you have to do the mapping. Yep. All right, so finally, notice that we have a primary key at the end. See that? Right. So that too, we need to tell on the Java side, we also need to make that clear. Who is the primary key? Right. And the way we do that is using the @id annotation. @id declares that that particular field, this course ID, is the primary key. Right. So notice that there's two annotations here. They both refer to that one field. Right. So these two annotations are saying that this maps to ID, and this is the primary key. You get two annotations on the same field. You can have 2, 3, 4, any number of notations that refer to the one field. You can have any number of annotations. What else? Okay, there's another annotation for course ID. Another annotation is that I might have declared the primary key on the relational side. I might have declared it as an auto increment, right? And that auto increment means that when I instantiate these objects, I don't have to provide the ID, right? This is going to be delegated to the database. The database is going to figure out what the primary key is. So I'm basically saying, don't bug me, don't bother me for asking me for an ID. The database will figure it out. Right? And the way we say that on the Java side is that we use the @generated value, saying that this value is generated by the database. Don't ask for this value when I instantiate you, right? And there's many strategies by which that value can be generated, depending on the vendor, right? Like Oracle, for instance, uses sequences, right? Where it'll generate a long list of unique identifiers from which it'll pluck, the unique identifier for that record, right? So there's a whole bunch of strategies. There's generation .identity, .sequence, .auto. There's a whole bunch of them. Identity for SQL and SQL Server, it means auto increment, or identity for SQL Server. So anyway, so we have now color coded every single piece of the relational world and how it maps to the Java world, right? The yellows, greens, and whatnot. Yes. Now, for most of the time, I mean, I went kind of all out here. The only real two annotations that are required are entity and the ID. Those are the only ones that are required. Right? All the other ones is because either the tables didn't match or the names didn't match quite right, or you want to automate a couple things. But the absolute minimum that you have to have is the @entity and the @ID. Those are the only ones that are actually required. Okay, so the DAOs. So the DAO that you would normally find that you might want to build would look something like this, right? For instance, if it's a course, you would have a course DAO, and you would have things such as find all courses, find course by ID, create course, update course, delete course, right? These are the 4 or 5 standard types of interactions you would have with any table, right? And if you do a lot of these, one for course, and then for sections you would have something similar, but instead of course it would be section, right? We have something like section. So there's a pattern here. There's a pattern, right? You could say, template, fill in the blanks, whatever you want here. So this could be parameterizable. If you pass me the section, right, I could generate for you everything else. If this would be parameterizable, if you pass me that as a parameter, I should be able to create for you this code, right? And that's what the ORM libraries do for you. They provide several of these repositories. Repositories are templates, right, of these types of DAOs. There's a whole bunch of them. One of the more common ones is the CRUD repository. The CRUD repository is parameterizable. It's a DAO like this over here, right, that you can parameterize. If you want to create a course repository or something that interacts with courses table, you can extend the CRUD repository. What is the name? CRUD, meaning it has functions to create, to read, to update, to delete, right? All the functions we just looked at. Those are a whole bunch of CRUD operators, right? You just have to tell me what is it that you're CRUDing, right? If you tell me a course, if you tell me a section, an enrollment, a department, a student, right? It can do all of them. As long as you tell it what data type it is, and this will tell it also what table you're talking about, right? Because you have an entity on that class, yes? And you might even have an at table telling exactly the name of the table, right? And it contains all the fields and all the data types and the names for those columns. So this contains everything it needs for the schema, right? And the mapping to the table it's going to talk to. Plus it needs the primary key, the data type of the primary key. Those two things, right? And boom, you can now interact with the table, right? So now you have that repository, you get for free these 4 functions. Yes. Which object? The actual Java object course? Which one? Here? You mean course repository? The CRUD repository? Or the course? No, the course is the same. That doesn't change. It's not parameter. That is the static, right? So listing all the fields and their data types, constructors and setters and getters. So it's a normal Java object, right? With the only added things that you've annotated it. So you could treat it as a plain old Java object. You can instantiate it new and use all the setters and getters, just normal, right? But when you annotate it, right now you can pass it on to the CRUD repository. And the CRUD repository is interested in the annotations. It says, ooh, these are the tables, right? And these are the fields, and these are the data types. So now it can write all the inserts, all the updates, all the deletes, all the select statements, right? That allow you to read and write to the database, right? Absolutely not. Yeah, it doesn't know anything about, it's not even aware that it's a database, anything. Actually, behind the scenes, when you say add entity, what the library does is that it creates what is called a managed object, right? And it re-implements all your setters and getters, right? So that if you call a set on your object instance, what it does is that it first it re-implements your setter, right? So that it does its own little magic. It calls your setter, right? And then it continues. Right. So as far as you're concerned, you're talking to your setter and your getter, right? But in reality, you're using a dynamic object that they create that has exactly your same signature, right? So for your purposes, you think you're talking to your actual object, when in reality, you're talking to a template that they create on the fly, right? And the reason they do that is that, for instance, if you read an object from memory from the database, right? And you instantiate it, now you have it in memory, okay? And as far as the library is concerned, that object instance in memory is identical to the record in the database. And it wants to make sure that those are in sync, right? Now I have a copy in memory and I have a copy in the database. If I make a change in the object in memory, you know, I change the first name, I change the last name. Now the objects in memory is out of sync with the record in database, right? And it needs to keep track of what fields are dirty, right? It flags the fields that are dirty because you did a set username, right? And because you did a set username, it keeps track of all the fields that you've touched, right? And it makes so it can keep track. It says, ooh, at some point I need to do an update on the record and database so that now the object in memory in RAM matches the object that is in the database. So it'll do an update, but it will only do an update on the fields that are dirty. It'll leave all the fields that you haven't touched. It'll leave them alone, right? So it's referred to as a managed object, not you treat it as if it were an instance, a normal instance Java object. But in reality, a lot of magic is happening behind the scenes. Not sure. I'm sure there is. Okay, so actually let's start off with the assignment, and I can demonstrate for you. Right, so we're giving you here, oh yeah, so the design of the assignment is to first have you work on the JDBC version of the DAO, right? Make you suffer through implementing an actual JDBC DAO from scratch, right? And then ask you to re-implement it, but using the ORM, okay? Whereas the JDBC implementation will be 10, 20 lines of code. When you do the ORM, it'll be just one line of code, right? Just to let you see the dramatic improvement of now sometimes you can't get away and you'll have to implement a DAO from scratch, right? If you have something very, very peculiar, right, that you want to do your own caching, or you don't like the way it's implementing the queries, or you have a very weird join between multiple tables, you'll have to rely on rewriting it yourself, okay? But for the most part, you should be able to get away with using just plain old ORMs. If you need to do something else in the ORM, then maybe you should reconsider your design. All right, so I'm gonna just clone down the project here. So everybody good with Git? Yes. Yes. All right, so starting from here, we're asking you to implement the following. So a couple of things here. First, under resources is the application.properties that configure the connection and the URL to your database. Okay, so for instance, this is where you would configure the name of the database, the username, password, whatever username and password you might have. The so as opposed to having it hard-coded in your source code, right? You could come here and change the username and password, the database, put it somewhere else, even change the protocol, and maybe not even be MySQL anymore. It could be Oracle, it could be SQL Server, right? And the source code should still work just the same, right? Without you having to manipulate anything there. What else? So in Java, we give you a couple things here. We give you the models, right, for a couple things. In particular, we give you the user object, right, already done, right? So you don't have to rewrite it. And notice that it's a plain old Java object, right? There's nothing peculiar about it, right? There's nothing weird about it. You will have to annotate it, right, so that this will map to a table in your database, right? We also give you a couple of DAOs, right, of which we ask you to complete, I believe, these two. So if you open up the JDBC DAO, and you're being asked to implement all these finders, find user by ID, delete user, update user, and this is where you do your work. So you're going to fill in these blanks here. And I believe we give you most of the code anyway, right? So your work will mostly be, making sure that the code that we give you actually works, right? And and perhaps tweaking a little bit, right? So that to make sure that this works for you. Find all users. So these are all the CRUD operations, right? Being able to create a user, be able to find all users, be able to update a user, be able to delete a user, be able to retrieve a particular user, right? And plus whatever, we have a couple of utility functions for you to establish a connection to a database. and close the connection. You should always close your connections. You know, the databases only have so many number of connections, and if you don't close them, eventually they will run out connections, right? You know, if you keep opening new connections, right, they will eventually time out. Yes, but if you do this, you know, enough times, and if it's only one server and you have, you know, there's you know 5 of you in your development team, right? Somebody's going to start complaining, hey, who forgot to close the connections? You know, because you know the database is out of connections, right? So don't be that person. Close your connections. We also gave you a starting point for the queries for you, right? We have the inserts for the create users, find all users, find a user by ID. Notice the placeholder. Yep. Remember, these placeholders are based on 1. So this is the first placeholder, the second, the third, the fourth, right? You can say set string 1, comma, and then the value. And you know, all the updates, delete, they're all there. Okay. What else? And then we ask you to, you know, instantiate it from main, and then just use these queries to create a few folks, you know, retrieve all the users, you know, delete a user, update a user, just use the API. That's what we ask you to do, right? Yeah, so once you've done that using JDBC, we ask you to do the same thing with the DAO with using an ORM instead, right? Notice that it's empty, almost empty, right? It has it's almost the same CRUD operations as before, yes? But notice that there's nothing in there, there's null. Because anyway, these are just going to be almost like one-liners, almost, right? 1 or 2 lines of code, that's it, right? And they're going to be written in terms of a repository, the user repository, sorry, the user repository, right? And the user repository, for the most part, is just going to be just the extension, and that's it, right? We do go a little fancy here, and you know, if back to the slides, go back to the slides. The functions that the repositories give you are very generic, right? Because you know, they're supposed to be able to interact with any table, yes, right? As opposed to your functions are very specific. You know, find all courses, you know, create course. They're very specific to course, whereas theirs is very generic because it can insert or update any table, right? So their names are generic. So instead of find all courses, it's just find all, right? And it can retrieve courses, sections, enrollment, students, anything. Same thing with find by ID. It doesn't say find course by ID. It says find by ID. You know, instead of create or insert or update is a .save. .save can be for both inserts and updates. Right? So it's smart enough to know which one, depending on the context. And find, you know, there's also delete by ID. So there's no delete course, right? But there's a delete by ID. And there's a whole bunch of other generic ones, yes? So, but you can optionally, where's repository? Wait, am I looking at the right one? No, that's not it. Let me close this. You can create the ones you want, you know, with the actual APIs that you want, and we'll come back to this a little bit later. But you can create your own specific queries, right? Not just use the native ones that are given to you, but you can create your own, right? And we'll come back to that in a minute. So anyway, so let's try using or implementing a couple of these guys, right? Let me get you started just here, okay? First of all, we'll need the tables. We'll need a database. Let's create a database. Let me create a database. So we'll have SQL, blah, blah, blah. MySQL. And we'll call it something silly. So we'll create a schema, and this will be, I'll call it DB design cs5200 and lecture. So brand new schema. And the name of the schema was, that's the name. So I'm gonna go back here, and in the application repositories, that's the schema that I'm gonna tell it right there. Right, that's the URL that's gonna connect to a database, right, with that schema. Yes? All right. And the username and password, I believe I have this username and password. Let's just let's see if, make sure. Okay, I do have a username, cs5200, probably the same password. Pretty sure that's correct. All right. Right. What else? So the schema, the lecture schema, no, not that one, this one. Notice that there are no tables. Yes, there are no tables. Now, one thing that I'd like to show you also about these ORM tools is that right here, there's a configuration. Not only does it ask me for a username and password and the login and the URL, but also it says, what do you want me to do about the schema? Right? In production, you would say nothing. I don't want you to do nothing. Yeah, I don't want you to do anything with the schema in production. Don't touch it. Okay, that's the database. These are the tables, right? These are the views. Don't touch it. Right? This is data that is live. People are using it. Right? We're not going to change the schema. But in development, right, us, we can play around. We can, it's my own little database here, right? We can say create. So you can create the schema for me. Instead of me having to create the tables from scratch and going, using SQL to create the tables, I can create the tables starting from my own models, my own data, my own database, my own classes. Right? Now notice this course has been annotated as an entity. I've said that there's a table called courses. There is no table called courses, right? There is no table called courses. I've said that this is a primary key. It's auto increment. I've even established the fact that a course has many sections. We haven't talked about that, right? There's a section also has been annotated as there being a table section. There is no sections table, right? It's empty. My schema is completely empty. There's a to-do table, to-dos. Also, there's no to-dos table. User hasn't been annotated because I've asked you to do that as part of the assignment. Okay, so the under here in the Java, under the same package where everything is stored, right, when we create the project, it creates a starting point, the kind of like the main entry point of the application, which is this one. Notice that it has the main is the entry point of the Java application, which I have here a run configuration, right? Which I can run. I'm going to run this main. So notice what happens in the console. It died. What? Anyway, notice what it did, right? It's tried to drop a courses table, tried to drop sections table, to-dos table, right? It created a courses table. See that? It created a sections table. It created a to-dos table. It altered the sections table, creating a foreign key. See that? If I go back to SQL and do a refresh, notice that it created a courses table for me, right? For which I can take a look at the create statement, right? So this is a create statement that the JPA ORM tool sent to the database to create the tables for me, right? It created tables with the ID. Notice it followed the naming convention ID, title, let's see, sections, the columns. I don't really have, oh yeah, see course ID, the foreign key, it followed the naming convention with underscores, right? What else? To-dos, what do I have for to-dos? I don't have anything. There's a due date in the to-dos, I believe. In the to-do model, there's a due date. Notice that it's using camel case, right? And it used the right naming convention for the SQL, and instead called a due underscore date. See that? And the data types made all the mapping. Yes. Yeah, there's annotations for each one of them. Yeah, so columns, you can give it defaults, you can give it initial values, yeah, not null, uniqueness, all that. Yeah, so if you notice even though you're using the table, notice that it's spitting out the SQL that it's writing. You're still responsible for the SQL, right? So it's kind of like the Teslas that are sort of driving for you, but you still have to keep your hands on the wheel, right? You're still responsible for what it's writing for you, right? What you're trying to automate is not that you don't want to. You're not going to be responsible for the SQL. You want to automate the fact that you don't want to have to rewrite all the code, all the boilerplate code, right? That doing the connections and iterating over the core of all the data. You want this to, you're still responsible. Yep. And many times you can override this. We'll see in a minute how you would override this and take control of the SQL. If you don't like the SQL that it's using, you can write your own. And we'll see that in a minute. Notice that it did not create the user table. It did not create the user table because it was not annotated. It was not annotated to be as an entity, right? So let's annotate it, which is part of your assignment. We annotate it as @entity. Okay. I'm going to and @ID. Those are the only two things that are required. Okay. So if we run that, if we rerun that, okay, notice that it created the user table. See that? But also it recreated all the tables again. See that? It recreated, so it dropped all the tables. So careful, right? Because this property, when you say create, it means that it'll blow away your database from scratch, right? And it'll recreate the table. So if you had any data in there, it's blown away, right? So definitely you don't want to do this in production, right? In production, say, no, don't touch my schema. This data in there, don't recreate it, okay? You could create something that is an update, right? Update will say, okay, well, there's a basic schema already set up, okay? And if I make any changes, like maybe I spell the name of the field something different, or I change a data type somehow, right? It'll try to alter the schema, right? But sometimes it's not very good at it, right? Some things that that you think you could alter, it does not alter them. So I like to, at least at the beginning, when we're starting from scratch, just to do a create until I'm happy with the schema, and then I change it to update, right? To just tweak the schema a little later, right? So for instance, one of the things in the user table that it did not do, let's refresh. Notice that it created a user table, not users table, right? Also, I don't believe it didn't add the auto increment, right? It didn't add the auto increment. So let's go back and refresh this, right? Go back to the user and annotate this to be instead override the name of the table to be users instead of the default user. And there's going to be a generated value whose strategy is going to be identity, right? So that's going to be auto increment in MySQL, and it's going to be identity in SQL Server. Okay. Yes. This is I am annotating that I don't want to be responsible for the value of the ID of this field when it gets instantiated before I send it to the server, to the database, right? Instead, I'm telling you, hey, otherwise it would ask me for it. It says, okay, you're instantiated, you're about to send it to a server, you're going to save it, you don't have a primary key, right? It's gonna complain. Instead, by annotating, it says, okay, fine, I'm going to try, I'll insert it without the primary key. And I'm assuming, as you're saying here, it'll be auto incremented, generated by the database. In particular, we'll use auto increment. No? Well, let's see, right? If I run it again, if I run it again, if I run it again, I refresh, notice that now I'll have two tables. So the one that I had created earlier, but now I have this users table that now is going to be, notice that this time now it has the auto increment that was not there initially, right? It's just the way it's represented either in SQL or it's represented in Java, right? And there's many strategies to generate it, right? Different databases do it differently, right? Auto increment starts at 1, 2, 3, 4. You can configure the steps, 10, 20, 30, 40. But the way Oracle does is completely different, right? It creates a separate table that has all the sequences from where you pluck all those values, right? So you would have to tell it, instead of identity, you can say, oh, it's Oracle, uses a different strategy, which is a sequence, right? It says, okay, well, all right, then there's a sequence, and if you say sequence, then you need to tell it what the sequence is called, right? You have to specify. You have to specify additional things, right? There's a sequence called yada yada yada, and pluck the values from there. All right. So yeah, so we have the user. And now we can start perhaps maybe inserting a couple of users. Let's see. There are no users. It's empty. There's nothing in there. So let's create a couple of users. Let's create here Alice. Alice. Last name is maybe Wonderland. Password is Alice123. Profile picture and username is Alice. Let's create a couple more. Bob. And this is Bob. This is Hope. Bob Hope. Password is Bob234. Whatever, and then Bob. Okay, so let's create these two users. Let's apply. So these are going to be inserted. So let's try and retrieve them using our JDBC ORM. Okay, so back in our DAO, there's our JDBC DAO. So we're going to try and retrieve all the users. So there it is, find all users. And the way we do that is we first get a connection. Once we have a connection, let's see, we need a prepared statement, right? So we'll prepare a statement. So prepared statement. So we're going to say from the connection dot prepare statement, and I believe I gave you a query called find all users. There it is. So that's a SQL statement that does select star from users, and then we're going to execute this prepared statement. We're going to say prepared statement dot execute query. And we're going to assign it to a result set, and we're going to iterate over it, right? So as long as there are rows to consume, I'm going to iterate over this. I'm going to collect, and I'm going to instantiate all these users. I'm going to put them in this users array. Okay, so this would be I would retrieve each one of the fields. It'll be maybe integer. The ID, what are the fields? I forget. Okay, ID. So this would be result set dot get integer, and the field is called ID. And I retrieve each one of these, right? So then you have a first name, result set dot get string, and then first name, first underscore name, and then last name. And then this would be last name. What else I have? We have the handle. And so first name, handle, last name, password. So password. And we have the profile picture. But it uses an underscore. And we have the username. Did we not have a username? Okay, username. And then we can instantiate the user. And I think we have a constructor for this, right? We have the username. Actually, I don't know what the constructor. I don't know what the fields are. Okay, username, password, first name, last name, profile. So username, password, first name, last name, and profile. Okay. All right, so I have one of them, and then I can add it, right? So it'll be users.add users.add user, and then it retrieves the users. Yes. Okay. So then I could use it here by instantiate from main. You know, the DAO gets instantiated, and I can retrieve the list of users. You know, list user users DAO dot find all users. Then I can display this, right? System dot out dot println users. All right, so let's run this. And it blew up. Wait, what? Declare the syntax unknown your schema. Oh man, what's that? Your schema. Did I miss something? Oh, your schema. What's the name of the database? What's it called? I think I put it in the properties. No, that's the name of the database. Okay, what else? Username cs5200 and password cs50. Okay, let's try it again. Okay, so it comes back with an array of 2 objects, right? We can improve that a little bit, going back to the users. We can override the toString so that it can display something other than just we say public string toString and return first name concatenated with with last name. Let's try to run that again. All right, so there's Alice and Bob. Right, so we are being able to retrieve it, and you would implement, you know, you would implement each one of these guys, right? You would implement the, you know, the find by ID. You would have to concatenate the ID. Well, not concatenate. You're using prepared statements, right? You're not doing that. Let's do one more, maybe. Let's do create user. We'll look something like, in this case, we're passing you an instance of a user, right? And so you are preparing the statement for inserts, right? So this would be a prepared statement with a connection dot prepared statement create user. Oops, create user. And then you can set. Let's see. Let's look at the. I forget the insert. The insert has 1, 2, 3, 4, 5 things, right? In the order in which they were declared, which I don't know the order they were declared. Let's take a look at it. They were declared. Where did I put it? Here it is. Must be this one, right? Oh yeah, so it has to be in this order. You have the ID first, right? And I believe that's auto increment, so we don't have to provide that. But first name, I just set up the first name, the handle, the last name, the password. So these first 5, right? Okay, so let's do that. So 1, 2, 3, 4, 5. So that's the first name, handle, last name, password, and profile picture. Yes, so let's do that. So in the create will be set string. The first string is the first name. So it'll be user.get first name. 5 of these, right? So that's position 2, 3, 4, and 5. So the second one is what? First name handle. So get handle. Then last name. So get last name. Password. So get password. And then profile picture. Get profile picture. So I'm populating each one of the prepared statement fields. Now we can execute the update. So we say prepared statement dot execute update. Right, it's going to be an insert, and that's it. Oh, rows updated. So rows updated is 0. We can, okay, so I believe execute update returns the rows. Yeah, int returns int. Returns the rows count on how many. Okay, so yeah, so we can assign how many rows were actually inserted, which is just 1, right? And we can use it for error handling and whatnot. Okay, so yeah, so I can now insert. I can create a brand new user. So user, Alice, Bob, C, Charlie. So Charlie, new user. And the constructor, what was the constructor for user? So username, so this would be Charlie. Oops, password. So Charlie 321. First name, Charlie, then last name, Garcia, and then profile picture, whatever. Okay, all right. So we have Charlie, now we can insert Charlie, yes. These statements? Oh, these constants? Yeah, these are just strings. They are strings, but they're compiled. So you could use the prepared statement multiple times. We are not using it multiple times. So these prepared statements, preferably they would not be in the function. They would be outside the function. So they would be compiled only once, and then you can use them any number of times. Here we're compiling every single time. Ideally, these would live outside, right? And they would have a specific variable name. Enum? Never thought of that. No, not enum. Oh, it could be a collection of them. Yeah, you could put them like in an array and then share them around. Like for instance, you can have a master DAO, right? And a master DAO can have controls many DAOs, right? And depending on what schema you're talking about, you could use one DAO versus another DAO. Yep. Yeah, you could do that. So anyway, let's see. So let's run this. So we have user Charlie, and we're gonna insert. So we're gonna say create user, and I'm gonna pass Charlie. And then I'm gonna do a find all DAO. So hopefully Charlie will be there as well. Okay, so let's run that. And that didn't work. Column count doesn't match at row 1. So maybe my query is no good. Let's see, 1, 2, 3, 4, 5. And maybe the order doesn't match. So insert yada yada yada. 1, 2, 3, 4, 5 users. 1, 2, 3, 4, 5, 6, 7, 8. How many columns do I have here? 1, 2, 3, 4, 5, 6, 7. Ooh, I have one too many. Okay. I'll take out one of these nulls. Let's try it again. Okay, there's Alice, there's Bob, and there's Charlie, right? And if I go to a database and I do a refresh on the users, hopefully Charlie will be there, right? Was inserted in there. All right, awesome. Look, yeah, it looks like the handle and the username didn't work very well, right? So maybe the order is wrong in the way it was created and the way I'm using it. Anyway, yeah, so there you go. That's you would go on and create your DAO of all the inserts and updates and deletes. Now, going back to the way you would do it in the ORM, let's take a look at that instead. Okay. So to implement the equivalent ORM, but I mean DAO, but using the ORM, let's take a look at find all users. What would that look like, right? So find all users, you would first need to create a repository. There it is, this repository. Right now, this repository, it's this fancy repository here. Let me throw that away for now. This is what you would implement. User repository extends CRUD repository, and you configure it saying, I want you to CRUD this user, and this is the primary key. That's it, right? And now I bring it into, I create an instance of it. There it is, right? Using AutoWired. AutoWired is implementing a inversion of control design pattern where you're not responsible for the life cycle variable. You let the infrastructure instantiate it for you, and then it binds it into your code, which is pretty cool. So notice that there's no new user repository. Right? So this is Java's inversion of control implementation, right? Different frameworks implemented different way. Other frameworks implemented as a constructor. You pass in the instance in the constructor, and then you assign that into your variable. Java can do that too, or using this AutoWired implementation. So anyway, so find all users. The way you would implement it using the repository is very trivial. It's very, very trivial. So to find them, you can just use the repository dot. Look at that. You have all these functions that are come out of the box. Find all by ID, delete all, count how many are there, how many records there are, delete by ID, find by ID, save, which is like an insert or an update. Okay. So let's use this one, find all. And we're going to return this, return. Now notice that it's complaining that it's not quite right? Because what find all returns, it returns an iterable. See that? Whereas I'm returning a list. Okay, that's fine. That's easy to. You can just cast it. You say cast this to a list. Right, you're done. Okay. Now, how would we actually test this? So to test this, I could create a main, right, and create an instance and run it. But I'm actually going to introduce a new topic, which is going to be a segue to what we're going to talk about next week. And is that instead of me writing a main function to use this, I'm going to make this available on the network, right? Let's make this available on the network, right? So by annotating this as a REST controller, it puts the entire class available on the network, right? I can now, if I know the IP address of where this is running, I can hit it and say and ask anything I want about this class, right? Now, usually there's many network connections strategies, right? There's FTP, there's UDP, there's all sorts of standards on how network connectivity happens on the internet. One of the more common ones, or more popular ones today, is HTTP. HTTP is one of the more common or more popular ways of connecting servers and clients talking to one another. And HTTP declares a whole bunch of methods of communication, right? You can do get, you can do post, put, delete, depending on whether you're sending data, you're retrieving data from the network, right? I can make this function available on the network by annotating it and saying, I want you to listen for an incoming GET request, HTTP request. And if the URL looks like this, right, I want you to return whatever that function returns, right? Let's try that. Let's run this again. Let's rerun this. Oops. Oh, I have another one that uses exactly the same mapping. I call it data. I have another one also called data. No, I don't. User repository, blah, 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 blah. What? Find all users. User repository. Oh, I sent that one. Which one are you using? Wait, repository. This one. This is the one I want you to use. User repository. Why are you using that one? Yeah, not that one. Okay, run that. What do you want? Go away. Okay, so it's up and running. Oh, you erased my records. Yeah, instead of create, I'm gonna say up. I'm gonna say none. Let me refresh. Yeah, it blew away all my data. Let's recreate it real quick. This is just Alice, Bob, and Charlie. Let's insert. Yeah, gotta be careful on that one. Okay, that should be okay now. All right, so this says it's up and running. It's listening at port 8080, right? And the IP address is just localhost. So I can say just localhost 8080, and I called it, what I call it, data users. There we go. So there's the data, right? That was in the database, which I only have Alice, Bob, and Charlie in those 3 records, right? And any new records I insert into a database, right? If I say Charlie, A, B, C, D, Dan, and Edward, right, is now available to anybody who knows my IP address. And if I put this on a public server, right now it's running on my local server on this laptop, but if this is be running on AWS or anything like that, right, it would be available anywhere in the world as long as people know the IP address or the name of the machine, right? And my data is now available, right? So this became very, very popular at the turn of the century, right before the dot-com bust, right? Where before everything went to hell. Companies were looking for ways to very quickly, they had all these legacy databases, right, that have been using in their enterprises, and they were looking for ways for folks to be able to integrate all these databases, right? Because somebody was running .NET, somebody was running Java, somebody was running, different infrastructure, and says, okay, well, can we integrate all our databases, even though you're running Oracle and you're running SQL Server and blah, 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 can we integrate our applications, right? And so they were looking for ways to collaborate and be able to share data. Then obviously the whole market crashed, but the technology survived. And today this becomes very, very common, right? So most big corporations will share a lot of their enterprise data with folks, and folks create all sorts of integration points, right? Where vendors and buyers will share data to be able to collaborate and automate a lot of their processes, right? And they use this technology, right? This usually referred to as web services running on the web. Okay. Anyway, let's do a couple more. Let's see. We did that one. Let's go back to the ORM. So find all users is as trivial as just doing that, right? There's no connection and iterating over nothing and creating objects and adding them to an array, right? It's just trivial. Let's create a couple more. So how about create a new one, create a new user, right? So let's first let's create a user here. So we'll say user. So let's see, I have user, new user, and I can provide a let's see, a username. I have what? I have A, B, C, D, E, F. So Frank, Herbert. I hope everyone has gone to see Dune by now. So we have Frank, Do. What else do I have for the user? Oh, username. Oh, crap. So username, password, first name, last name, profile. Frank, no. Okay, so I have the user. I think I have the user, right? And I'm going to save it. I'm going to insert it into a database. And I can just do that very easily by just saying user repository dot save. I can pass in the user object. See that? And the user, and notice that I'm not providing the ID. Okay, this is going to insert it into a database, and it returns the actual object that was inserted in the database, including, for instance, the primary key. Right. So whatever was generated on the database, right, it'll be populated, right, and it will be returned to you for additional processing, right? So I'm going to expose this as well, make it available on the network. I'm going to say get mapping data users create. So let's run this. I can do here users create. So notice it created the user with all the data, Frank, Herbert, yada, 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 and the ID is 6. So that looks promising. If I go back here and I refresh, notice that indeed Frank made it into a database, right? So it inserted and saved it, right? You can actually should be able to see the actual query that it used, that it sent to the server, right? I use this insert statement, okay? So you can look at what it's doing. Maybe you don't like it, right? You don't like that. That's the and then you can tweak it so that it behaves exactly how you want it to behave. But notice this is kind of lame, right? That it's always inserting the same user. We could pass in as an argument here a couple of things. We can pass in the first name, or maybe F name, the F name and last name, and pass in maybe the username. So I can declare path variables, right, that I can pass in as with values, pass in the password, and then I can parse this from the path as arguments. I can declare F name. I can declare these individually. Last name, and then the username and the password, and say that I want to parse all these values from these placeholders that are going to be passed as part of the path, right? So that I can retrieve the path variable called first name, and it's going to be passed to the function as a parameter. Okay, so let me copy this. So this would be last name, this would be a username, and this would be the password. Yes. So I can, and then I can use this here. I think this is a username. This is a password. The first name. So instead of being always the same thing, and I'll just leave the profile the same. Okay. All right. So if I restart this and I go back to the query, and instead of create here, I say username. So Frank. So Greg 321. I think it's username, right? No, oh no, first name first. So Greg Daniel. So first name, username, password, blah, blah, blah. Okay. So I'm passing that, and notice that that's what gets inserted in the database, presumably. Let's go back here and refresh. And indeed, we're able to insert Greg. Yeah, so now it's parameterizable. I can pass in parameters instead of being something hard-coded. So, but notice how trivial it is, right, to just interact with the database instead of having to build a string, populate it and blah, 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 right, and prepare the statement and handle the response. Let's see, what else? How about find user by ID? Oh, notice that if I go back, right, if I refresh, notice that this find the users, right, it's still, you're still returning even the brand new records that I had earlier, right? Still there. How about find by user? Let's implement that. So find by user, I'll still be using the same repository. Notice the find by user has a find by ID. See that? Find by ID. But notice the return type. See the return type? You would expect that it would return a user. Instead, it's returning something that contains the user. So not the user itself, but something that wraps the user, right? So if I say find by ID and I give you the ID, right, I can't just return this. Well, almost. It's complaining. Right? And it's because it's really returns a, what's it called? Optional or something? Yeah, returns optional. So optional is, it's this particular library's ways of dealing with something that could be null. That you give me a primary key that doesn't exist, right? And I fetch a primary key, it fails, right? So it comes back with a record doesn't exist. So optional allows you to deal with this error message, right? You know, you can check, is the record there? If not, then you do something else. But I'm going to be lazy here, and I'm just going to unwrap the content. I'm just going to say get. And get actually unwraps the content, gives you the actual record, right? Which is a user, which is an actual user. Okay. And so I can map it. I can say map this to the following URL. You know, if I give you the ID, if I give you a user ID as a parameter, I can parse this out of the path and pass it to you as a parameter using the same at path variable. The path, parse the user ID variable from the path, try to convert it into an integer. You know, make sure that it parses as an integer. Okay, so if I send something other than an integer, this will fail, will throw an exception, right? And then use it normally to retrieve. So let's restart. So now if I say number 6, I can say users 6, right? It returns that one record as opposed to returning all of them, that one single record. Make sense? All right, so now notice that we had to do this, you know, this kind of bogus thing of having to wrap it and cast it and do the get. It's not exactly what we want, right? So you can override the query. It's using, probably is using the query that you want, right? But it's wrapped into this funny looking API that is not specific to us, right? It's very generic. You can override that and tell it exactly what query you want it to use. So you can take more control of the actual SQL that is being used underneath, right? And you can also wrap it in an API that makes more sense to you, that is maybe more tailored to your specific needs, right? So for instance, this user repository declares all these very generic functions, you know, find all, find by ID, you know, create, save, things like that, right? But we can override that. We can go and into the repository and create our own API. We would say, wouldn't it be great if you had instead something that would be something like, you know, list user find all users. It'd be great if we had that, but we don't. It'd be great if you had user find user by ID, and I pass you the ID. It'd be great if you had that, but we don't. Well, actually, you can. You can declare your own API. Right? In addition to what they give you out of the box, you can create your own API. Now, you don't like exactly how the join is being handled, and it spits out the query that is being sent out to the server. You might not like it, right? It says, "Ooh, I don't like the order of the tables. Maybe I want to do a left join first, blah, 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 whatever," right? You can specify exactly the query you want. So for find all users, you can specify exactly the query that you want without actually doing the work, the grunt work of iterating over the result set, instantiating all the objects, and doing all that, right? Which that's the tedious part. Here, you can just say, well, I want you to use the following query, right? For that find, for this find here, use the following query that has the following value I want you to use select star from users, which is not, it's not very exciting, right? It's just a select, right? There's nothing peculiar about it. And also notice that I'm going to have to say that this is native. It's a native query, true. Okay. The reason is that by default, this library uses a version of SQL that is high level. It considers this language, this SQL language, to be very has way too many dialects, right? It says, well, you do it one way in Oracle, you do it another way, do it in SQL Server, you do it another way in MySQL, right? So instead of forcing you to know the idiosyncrasies of each different vendor, right? It allows you to write it at a very high level as follows. You can say instead, select user, user, meaning select all users of type user, right? And what's user? It's a class, not the table, okay? Which the class happens to be related to a table, right? So it parses this and it converts it into the equivalent SQL for your specific vendor. If you do, if this it's implemented one way for MySQL, it will write that, right? If it is implemented for in SQL Server, it will write the SQL Server version. You can specify here the dialect. You can specify the Hibernate dialect that you want to generate, right? So if tomorrow you want to port this same code to Oracle, you can say, oh, I'm using Oracle version 8.3 something, 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 right? It says, oh, and then it knows how to translate this high level language to that specific dialect, right? So this allows you to not be married to a specific vendor, right? It allows you to, distance yourself, okay? So this one, find user by ID, would be something like this. The query. So this, instead of being called SQL, SQL, it uses JPQL. So Java Persistence Query Language. It's a higher level language. It's an object-oriented SQL, right? And you'll see in a minute here. For this one, the version for here would be something like select user from user where user.id equal, and then a placeholder. Okay. So since this is a placeholder, where do we get this value? We get it from here, right? So somehow we need to map this ID to that user ID. And we can do that by saying that this is the parameter param user ID. So this ID, which is coming as an argument to the function, I'm mapping it to the placeholder of the query. Okay. All right, so now that we have our own API now, right, written in our own language, our own SQL, and it has this more specific API tailored to our naming convention. Instead of we can now use that instead of using this very generic versions. Instead of using this find all, we can rewrite this using this more specific API, using this query that we want. We can say return user repository, find all users. Okay, this is a more natural use of the API, right? Right, specific to our domain. And same like this one, right? We can say, return user repository dot find by ID, and I'll give you the ID without the need of doing a get, right? It's the correct data typing, right? If we restart this, let's see if this blows up. And hopefully this works just the same. If I refresh, there it is. So it still works the same. I can get number 5, number 7, that still works. And user still works, just the same way. Make sense, right? Yeah, and you can write you can rewrite everything you want in the repository. Right, you can rewrite your own deletes, your own inserts, your own very weird joins, right? That are joining three tables, right? Would be all implemented here. Make sense? All right. Now this is a CRUD repository that deals with SQL. There's also non-SQL repositories that deal with Mongo or deal with Firebase, and with other databases that are not relational databases as well. So there's a plethora of repositories that are specific to different other types of technologies, which are pretty cool, but escape the scope of this lecture, right? All right, that's all I had for you. And so yeah, we're the assignment basically asks you first to implement the table, the class, the user class. It'll ask you to create the JDBC DAO, right? Being able to do all the create, the find by ID, the delete, the user. You're gonna implement that just like we showed you. We give you most of the code, right? So basically, you have to make sure that that actually runs. We tell you to insert some folks in there, Adam and Thomas and Catherine, create the users, then retrieve all the users, find all the users, then retrieve by ID, delete by ID, update by a user, and then do the same thing, but with an ORM, right? Obviously, you'll need to configure this with your own database, your own username and password, right? You'll have to annotate, right, the tables and entities, create the repository, right, and then use the repository to implement all these functions, which we created 3 of them, right? So create user, I literally give you everything, right? The mapping, the REST controller, retrieving all the users. Oh, okay. Here I gave you a native version. We did a non-native version. The one we did was a JPQL. This one's using a native. So if you're not using the high-level object-oriented SQL language, you can say, oh, this is native. Native meaning this is literally the string I want you to use. Don't interpret it. Don't try to understand it. Send this query to the database. Just like this, just like the way I give it to you. Don't try to make sense out of it, right? So if you have any syntax errors, right, the server will let you know, right? There's this. And then do the same thing, but for find all users, find by ID, delete, and update the user. Okay. Make sense? All right, excellent. Any questions? Yes. Yeah, so you would have to mock the DAO and mock the JPA, so it doesn't actually go to the database, and so that, and then your mock would have to respond what the database would respond, right? And so that, and probably those responses would also be parameterizable, right? So that if you insert certain pieces of data, then the response would have to also be parameterized based on what you passed in, right? So it's an array or whatever, right? So because the idea is that you want to decouple the testing from other dependencies, right? So you can do unit testing so that you don't actually have to have the database running, because what you're trying to test is the code, right? If you're trying to test with the connection to the database, then that's not unit testing, that's integration testing, right? You want to make sure that the actual integration, the connection actually exists, right? And then you probably have a test data, like databases for that have data that is there, and that when you query, you're expecting that data to be retrieved, right? Are you talking about unit testing, or are you talking integration testing? Yeah. Yeah, no, you have different types of mocks that will mock a database, will mock a web service, will mock things that would be other resources that isolate your code, right, and provide a fake version of those resources. Yeah. There's I mean, there's several, right? There's Mockito, there's Jasmine, there's a Karma, there's a whole bunch of them that allow you to create all these mock. Well, to create the data, that you have to do it by hand. But setting it up doesn't. Unfortunately, not. Most testing is integration testing. Unfortunately, they'll run the whole thing, right? And they'll even do functional testing that tests the entire thing, right? And that's not very it's not very reproducible. It takes it's very manual, and it's very hard to identify like regressions, like you fix something, but you actually introduce a bug, right? And now your unit tests, there are no unit tests, would not capture that, right? You would have to do a whole integration testing to capture it. And unfortunately, that's still the most common way that people test. Just do a full integration testing. And usually there's way too many edge cases that would just take too long to be able to capture them all. Whereas unit testing, right, allows you to just isolate and only test individual elements, right? And it's in a much reduced set of states. Right. The problem is that when you do integration testing, you have a combinatorial explosion of all the possible states that an application could be, right? And so well, how do you possibly, right, consider every single possible state, right? It's too big, and that's why you try to do unit testing where you have a very reduced set of possible states that that if I give you this input, that's the output I expect, right? And if I'm confident on this little unit testing, then I can build confidence in the overall application. But many companies don't have the rigor and of investing that kind of I guess I shouldn't say that. I have the good fortune that most companies I've worked at, they do a lot of unit testing.
Is it okay to do unit testing against the copy database? We don't have to log?
That's still integration. Yeah, that's still integration. Well, I mean, it's a little better, if you do the unit testing on that small little unit with that just goes out to the database. That's still better than nothing. Yeah, but ideally you want it to be independent. Yeah. All right, awesome. Anything else? All right, thank you. How about online? Everybody okay? Any questions? Yes. Mm-hmm. Open the resources. Now, application property. So that's the database. Those are users and passwords. Is that database name correct? Right. And you have that username and password. Is that right? You have that?
From
Yeah. So go to administration. No, go back. The administration users. Okay, these are all the users you have. Okay, you have cs5200. Do you remember the password?
Yes.
Okay.
But is that the issue?
Yeah. So go back here. And is that the password? Is that correct?
I think it was just like.
will the other code work?
Well, I don't know. Let's see.
Because,
Let's see what it says.
Like, there's a lot of errors, so I'm sure there's.
What's it complaining about here?
Does it come from like Spring?
Yeah, it's not finding that. It's finding that. What?
Yeah.
Example. Example. String, well, models. Course. Huh? Maybe something's wrong with course. Oh, interesting. It's not finding that XML. Fine.
I click that, I won't take that 4 hours. Just crash it. Oh, it's okay. I'll try and then maybe I'll catch you in office hours tomorrow.
So yeah, we need to. Why is it not finding faster?
Maybe there's some.
Can you stop it? Maybe restart it.
Okay.
See if we can.
Like quit.
Yeah, quit maybe. Oh, you have